Okay, so here we're going to talk about functions. Functions are a very important topic in mathematics. You'll talk about it in Algebra 1, Algebra 2, college algebra. Basically, every math class you'll take, you'll talk about this idea of functions. We're going to start with kind of a relatively simple definition. And a function is just a relationship that pairs an input with an output. Oops, there's no O in output. So it's a relationship that pairs an input with an output. We're going to call these inputs the domain, and we're going to call the outputs the range. So the inputs are all the possible values that will go into the function. The outputs are all the possible values that will come out of the function. A lot of times in math, the domain is the x values, and the range is this idea of y values. So we have inputs, outputs, x values, y values, and then we'll also call them independent variables and then dependent variables. Okay, so the first thing is just to kind of make this connection between inputs, outputs in this domain and range. So in this first example, the input-output table shows the amount of money Michael earns at his job for several numbers of hours. So this is a function. Identify the domain and range of the function. So the domain, and here we would just list all the numbers in the domain, but the domain is 2, 5, 7, and 8. And you can put those like fancy curly brackets around it. That's a good notation. If you don't at this point, it's not too bad, but I would try to put them there. And then the range is the output. So it's the dollars he makes. He makes $14, $35, $49, and $56. So this is the domain and range of this particular function. Now, if we were to extend this, there could be more, to the real world. In this example, the domain could actually be more because maybe he could work, 2.5 hours or 3 hours, and then his dollars that he earns would change. The amount of money he earns would change. But here we're just going to go based on the table. The input are those possible hours, and the output are those dollars. Okay, and this concept of a function is a pretty difficult one, especially domain and range is a difficult concept. So we can use these diagrams called mapping diagrams to maybe help clear up some of these. And you can see the input here is 1, it goes to 0. So it's just a way to pair inputs and outputs in the domain and range. Okay, so to determine whether each pairing represents a function, so for a function to a relationship to actually be a function, then it has to follow this rule. Notice that any output may be paired with more than one input, but no input is paired with more than one output. So you have to know what you're going to get. So for a function, the x values, actually let's use inputs instead. Let's say inputs cannot go to more than one output. Or a kind of a shortcut way of saying that is, or seeing that is, the inputs can't repeat. So if the x values repeat or the inputs repeat, then it's probably not a function because that means that same x value or that same input's going to two different outputs. There's a lot of different analogies for this. One is a pop machine. Like if I were to go up to a pop machine, put my dollar in and press Pepsi, I expect to get Pepsi every time. And there could be multiple Pepsi buttons. That's okay, as long as they give me Pepsi every time. But if I press a Pepsi, I press the input button, and sometimes it gives me a Pepsi, and sometimes it gives me a Dr. Pepper, then I don't know what I'm getting, and that's no longer a function. So a functioning pop machine is a function because you know what you're getting every time you press that button. Let's look at these and determine if these are functions or not. So determine whether each pairing represents a function. So we're looking, do the x's go to just one thing. So every time I put in 2, I get 0. Okay, that's good. Every time I put in 4, I get 3. Okay, that's good. Every time I put in 6, I get 3. Now, 2 different things give me 3. That's okay because 4 always goes to 3 and 6 always goes to 3. So the outputs can repeat. Every time I get 8, I get put in 8, I get 5. So yes, this is a function. Okay, now let's look at B. So if I put in 1, I get 2. If I put in 2, I get 3. If I put in 2, I get 4. Okay, so here's where these inputs repeat. So sometimes when I put in 2, and we can map this out this way also. So 1, 2, 4, those are the inputs, and then 2, 3, 4, 5. So 1 goes to 2, but 2 goes to 3, and 2 goes to 4. And then 4, that's 6, not 5. 4 goes to 6. So this is not a function because 2 sometimes gives you 3, sometimes gives you 4. It's confusing. You don't know what you're going to get. And so we say it's not a function.